Alright, this video will act as your introduction to Chapter 4. Chapter 4 is mostly about types of reactions. It is one of the hardest chapters we will cover this year. And because of the way the new AP curriculum is, I also have to incorporate another chapter called Solutions into this chapter. The first thing we need to talk about is what is a solution. The word aqueous means dissolved in water. So anytime you hear the word aqueous solution, whatever it is they're talking about is dissolved in water. For example, an NaCl aqueous solution means salt is dissolved in water. Water then is acting as the solvent. The solvent means it is dissolving whatever is being put into it. That thing that's being put into the water is called the solute. So the solute is whatever is being dissolved. The solution is a word that combines both the solute and the solvent. For example, in Kool-Aid, what is the solute? The solute would be the powder because that is what you are dissolving when you make Kool-Aid. The solvent would be water. That means that Kool-Aid is an aqueous solution, and the solution would incorporate both the powder and the water, which is the solvent. So the solution is the Kool-Aid. A couple things you need to talk about in regards to water. Water is special because of the fact that its shape is bent. Not that it's the only bent molecule in the world, but that is part of why it is so special. Its bond angle is 105 degrees, which means that both the hydrogens kind of point in the same direction, which is generally in this picture down and to the right. The OH bonds are polar covalent. Remember that polar and covalent each mean something different. So covalent means that the hydrogens and oxygens are sharing electrons. Polar means they're sharing unequally, okay? Non-polar is when they share equally. Since the electrons are being shared unequally, they are moving towards one end of the atom. To decide which end of the atom is drawing the electrons nearer to itself, we look at electronegativity. Electronegativity is the ability to draw electrons to an atom, and in this case, O is more electronegative than hydrogen. Since the O is going to be more electronegative than the hydrogen, okay, it is pulling all the electrons towards itself. So it's going from here, let me get my pen, towards the oxygen. The net electron movement then makes this end of the oxygen atom to have more electrons than the hydrogen end. That means the hydrogen ends are left with partial positive charges, and the electron ends are left with partial negative charges. All the electrons are gathering near the oxygen. Oh, wrong way. Hold on. Okay, so just to re-show you, all the hydrogens are pulling the electron, or losing the electrons, are heading towards the oxygen. And in this case, all the electron density is near the oxygen. It becomes a negatively charged part, and the hydrogens are positive. Now, in hydration, okay, the word hydration refers to when a water molecule surrounds itself around a salt. Okay, so a water molecule is polar, which means it has a positive and negative ion end. Okay, it's not really an ion, but an end. It's similar to an ionic compound because remember, ionic compounds have a positive and a negative, similar in the way that a water molecule does. Ionic compounds are also called salts. You're going to hear me say this many times throughout the year. So if I say ionic, you have to think salt. If I say salt, you have to think ionic. Okay, they are the same thing. The word hydration refers to when water molecules surround a salt and they cause it to fall apart in water or to dissolve. Just like you see in your everyday life. You put a sugar cube in water, it's going to eventually fall apart. Hydration refers to what's going on at the molecular level. The strong forces that are present between the positive and negative ions of a solid like salt are going to be replaced by strong water-ion interactions. So I'm going to show you a video. See if I can get it to come up. Alright, I'm going to play this video for you. While you watch it, notice what the water molecules are doing to the salt, which is the green and gray solid in the middle. The water molecules come in, they surround the ions of the salt, and they literally pull them off. Okay? Now, on a close-up view, watch what happens close up. Notice that the hydrogen and oxygen ends are all attracted to the same ion. So in that case, all the reds are connected to the gray ion in the middle. Remember that the reds are oxygens. The oxygens are negative, which means that the ion in the middle must be a positive ion. Okay? Now watch what happens when they want to surround a green ion, which the green ions of the solid have to be the negatives if the grays are the positives. In this case, all the hydrogens are attracted to the green ion because the hydrogens are positive and the ion is negative. So whenever you see a picture involving water, pay attention to what side of the water molecule is attracted to the ion, and you should be able to deduce what charge the ion is. Okay? Alright, now, just to recap. Hydration happens when the positive ends of water, the hydrogen ends, align with the negative ions of the salt, and the negative ions, or negative ends of the water, the oxygen ends, align with the positive ions of the salt. And there's a few pictures to show you and remind you. Again, same pictures, just look at which ends of the water molecules are facing the ions. Now, after hydration has happened, all salts are broken into their individual cations and anions because they've been pulled apart by the water molecules. So when ammonium nitrate dissolves, for example, as a solid, it starts off as a solid, and in the end, it looks like it's two ions, an aqueous ammonium ion and a nitrate aqueous ion. Same thing happens with lithium carbonate, which is also a salt because it's ionic. But when lithium carbonate dissolves, it produces two lithium ions and one carbonate ion. So you don't forget you also still have to worry about the stoichiometry involved as well. Solubility. Solubility is defined as the amount of a substance that dissolves in a given amount of solvent. The reason it has to be a given amount of solvent here is because the more water you have, the more salt you can technically dissolve. But if you're basing it on the same amount of water or solvent that you're using, the solubility will depend on how attracted the ions are for each other and how attracted those ions are for water. It's a competition between these two forces, and we'll learn more about this in our solubility chapter. For now, you need to know about strong, weak, and non-electrolytes, okay? An electrolyte does not just mean Gatorade. It means anything that is able to conduct electricity. There are three types of electrolytes: strong, weak, and non. Strong electrolytes will conduct current efficiently. Weak electrolytes will only conduct a small amount of current. Non-electrolytes do not conduct current at all. So what determines whether it's a strong, a weak, or a non? It depends about the number of ions that are made upon the process of hydration being completed. So for example, in the left picture with the green and gray ions, you can notice that you have quite a few anions and cations when hydration is complete. In the middle picture, you only show one cation and one anion. Not very good. And in the right picture, you have absolutely no ions. This is approximately what it would look like to be a strong, weak, and non-electrolyte. If you were to test these by hooking them up to a conductivity probe, the strong electrolyte would light the bulb very brightly, the weak would barely light it, and the non would not produce any electrical current whatsoever. For me and my purposes right now, I really need you to understand that which types of compounds are strong, weak, or non-electrolytes. Strong electrolytes are salts like ionic compounds because they are hydrated very well when surrounded by water. They will produce a lot of ions. Strong acids and strong bases, like I asked you to memorize, these all will break down completely when placed in water, which makes them strong electrolytes. Weak electrolytes are any weak acid, so anything that's not on your list of strongs, including anything that has this what I call Cu group attached to it. The Cu group is the carboxylic acid group that you will learn when you later take organic chemistry in college. The carboxylic acid group is a weak acid, so if you notice the COOH group on the end of a compound, it's a weak acid. Weak bases are also weak electrolytes, like NH2 containing compounds or the ammonia, compound, which should be NH3. Polar covalent compounds are also weak electrolytes because they have a slightly positive and a slightly negative end, just like the ionic compounds do. Non-electrolytes would be anything that is a non-polar covalent compound because their electrons are not shifting, and that any compound that starts with C and ends with an OH group. These are called alcohols, which is another functional group that you learn in organic chemistry, like the carboxylic acid. Remember though, this can be confusing for students. If it starts with a metal like LiOH, that's a strong base, so it's a strong electrolyte. But something like this that also ends in OH is not a strong base because the beginning part of this is not a metal. That makes it a non-electrolyte. CH3OH is an alcohol known as methanol. Make sure you can recognize the difference between a strong base and an alcohol. That completes our video. Please make sure you fill out the worksheet and turn it in before school on Monday to receive your credit. And I will see you then.